Welcome to Runtime Atlas. Today we will understand pods, the smallest deployable unit you create and manage in Kubernetes. Quick recap. The scheduler chooses a node for work and the kubelet on that node makes the pod actually run. A pod is a wrapper around one or more containers. Most pods have one app container, but sidecars can live in the same pod when they must work closely together. Containers inside the same pod share the pod network. They use the same pod IP, can talk over localhost, and can share volumes when they need the same files. A pod runs on one node at a time. After scheduling, the kubelet works with the container runtime to start the containers on that node. A pod moves through phases. It can be pending while Kubernetes prepares it, running while containers are active, then succeeded or failed when the work is done. Pods are not permanent pets. If a pod is deleted or replaced, the new pod is a new object and usually gets a new IP address. That is why we usually do not manage long-running pods by hand. Controllers like deployments and ReplicaSets create replacement pods to keep the desired state. A pod manifest describes the desired state. The spec names the containers, images, ports, volumes, and other settings Kubernetes should apply. Here is the mental model. A pod is a shared runtime wrapper for containers. It runs on one node, has a lifecycle, and is usually managed by a controller.